All right. So I am super happy to see all of you here. I was really surprised how popular this event is. The last time we ran an iOS developer meetup in a place where we don't usually run it, it was very popular as well. It was in Copenhagen. So if you are interested in joining us in Copenhagen again, let me know, and might put it on again. So, and because it's not very often that I get to see so many people from the stage in the Google office, we absolutely need to do a stage selfie. So I'm going to take a selfie, and you need to scream like at the top of your lung. Let's scream NSLondon. And let's do a video, actually. All right. 1, 2, 3, NSLondon! At Google. At Google. Great. All right, so with that out of the way, we can get into the talk. So this talk originally was called How I Built an Exobrain using Firebase, SwiftUI, OpenAI, LangChain, and Siri. And then across the past couple of months, I swapped out a bunch of technologies, and now most of those technologies, except for iOS and Siri, are Google technologies. So please bear with me. We're at Google, so I think I'm entitled to talk a little bit about Google stuff. If you want to follow me, at Peter Friese is my handle pretty much on every platform, on Twitter, or X if you want to call it that way, Threads, LinkedIn, Xing if you are from Germany, and all the other ones. I'm a developer advocate on the Firebase team, so I work with the people who built the iOS SDK that some of you might be using. I've had a hand in building some of the features. So if you use Combine, that was me. I still think it's a great thing, right? So whenever I have to build something and I can't use Combine, I'm like, oh, this used to be so much easier. And these days I do a lot of stuff with AI. So I've built the very first Swift implementation of the Google AI SDK for Gemini, which we have migrated to a newer version. And today I'm going to talk to you about an even newer version. All right, so making Siri smarter, is such a thing even possible? There is a really good podcast I listen to. It's called, I forgot what it's called. But there is a guy who likes to complain about Siri in every single episode, and he has given up on Siri getting smarter. So maybe today we'll see how it is possible. So the problem that all of us probably are facing is information overload. So there's a bunch of blog posts that you run across every single day, so much documentation that you come across every single day, and there is not much time to read it. And that is why this fellow here would probably say there is an app for that, which helps you. And we have a bunch of options here. Remember some of these? Instapaper, the Reader app, Goodreads, and a bunch more. But, oh, we didn't have audio. Can we do that again? Let's see. I'm on audio. There you go. So the problem is not invented here. And we always make fun of Google because we have so many messaging apps. I'm not telling you that what I show you today is an official app, because it's not. It's just like something that I built myself. And one of the reasons why I built it was that I run this newsletter and I needed a way to curate the articles that go into it. And usually what happens is I'm on my phone, I'm idling around, and then I browse Twitter, I browse the What's New tab in Chrome, and I come across all sorts of interesting things. And I'm like, oh, yeah, this would be a good thing for the newsletter. So I want to save them. And the engine I use here is called Curated, and it does have this really nice input field here. So when you want to add something, then you can go into this form, input the URL, input the title, and then type in the body. So that's a lot of work. But they also have an API. And so I thought, why not build an application that I can use to collect all those articles and all those links, and then just send them over to this URL to have them added to the newsletter. And as you can see, you can pass in the URL, the title, and a description. And obviously, I write the description myself, because that is the added benefit of the newsletter. But why not get some help? So the solution is to read stuff later. And I've got this little application here, and let's see if I can give you a quick demo of how it looks like. If I can mirror my screen here. Let's see if it works. There we go. All right, so plenty of other apps there, and this one is called Sophia. And it's just a simple list of all the articles I collected. You can add a new one using this dialog here. There's also a share sheet, so if I go into Safari, press on the share button, it will come in here. And then when I go in here, you can see a readable version of the article. So all the extra formatting has been removed, which you'll see if I click on this one. So this is how the article originally looked. So for this one, removing the formatting probably is not that much of a great idea because it's already pretty clean. But if you consider something that is maybe has more ads and stuff like that, it makes sense, right? Okay, so this is the main functionality of the app, and that I started a couple of years ago, and it was really just a thing that helped me to collect links. All right. But there is this problem. I still need to read all those articles. So what can be the solution? The solution is, of course, to automatically summarize these using AI. So in the beginning, I told you I used OpenAI, but for this one, I used Gemini. So if you want to use Gemini, you can go to this URL here, ai.google.dev, and then you can see this UI. And I thought it would be nice to maybe show you a little bit how it works. So let's go here. ai.google.dev. So this is the landing page. It tells you a little bit about the product. You can see that you can use it from Python, Node. You can directly call it on REST, Go, Android, Dart, Swift. And then when you want to use it, you click on Get API Key in Google Studio. And I started writing a blog summarizer. So if you want to summarize a blog, you probably want to have a prompt something like this. Please summarize the following text for me, provide a synopsis in less than 5 sentences, and add a list of up to 4 tags for categorizing the blog post. So, and everything below that is basically just a copy of this article here. So because I wrote this myself, I went into the Markdown file, copied the Markdown file, and pasted it here. And you will notice that AI Studio already does some nice formatting here. So it understands what's a heading, it understands what's source code and all of that. So really nice. And then I can just click on Run. Let's scroll to the bottom so we can see what's going on. All right, so this is the answer that we got in just about 4 seconds. This blog post demonstrates how to implement a hero animation in SwiftUI similar to the one used in the App Store's Today view. So, and that is a really good summary of the article. And then it gives me the tags, SwiftUI, hero animation, App Store, iOS development, and navigation. So that's pretty cool. And on the right-hand side, I can configure the model. So I can change the temperature to influence how creative the model is and how wild it will go. And then I can switch between the different models I can use. Flash is our fastest one at the moment. And then I can adjust a couple of advanced settings. For example, I could tell it to give me output in JSON. And then let me just change the editor so that I can regenerate. Hello? Oh, does it not work in Flash? Gus? Yes. No JSON in Flash? It should, right? Oh, there we go. It's just the UI. Oh, I know. I need to remove this one. OK, great. OK, let's run it again. And now we get JSON. And it is already pretty smart. It says, this is a summary, and these are the tags. I didn't tell it to use those, right? Amazing. So this is the start of building this feature, right? So I can now go in and play around with the prompt. I can fine-tune the prompt. I can fine-tune the model. I can play around with generating JSON or not. And then once I'm ready, I can say, well, I want to use this in my application, but I don't know how to write the code. So I could either go and read the documentation or just tap on this code button here and then switch the language I want to use. And then it gives me this really nice code snippet that I can use in my application and paste it or adjust it a little bit. All right, so that is how you can make use of AI Studio. Let's go back to the presentation. You can use Google AI SDK to access Gemini models, and we've got SDKs for a bunch of languages like Python, Node, Go, Kotlin, Dart, and Swift. And the recommendation is to use this SDK for prototyping because it has a relatively low RPM. So you can, I don't know the exact number, but you can't run thousands of requests per minute, but fewer. So it's not intended for production. And also, the biggest drawback is that you have to put an API key in your application. And as many of you probably know, if you put an API key in your application, anyone can go and take that API key and then send requests to the model on your behalf. And that will ultimately cost you money. And that's not good. So we thought, what can we do to make this a better experience for developers? And we have a platform that is called Vertex AI. And that is an AI platform based on Google Cloud. It is made to scale, and you can choose from very many different models, and it is made for production. You can still use the same Gemini model that we used in the prototype, and we've got SDKs for Swift, Kotlin, JS, and Dart, and it's part of Firebase. So that means if you either already use Firebase or you're OK with adding Firebase to your application, then it's pretty easy to get started. So all you need to do is go into your Firebase console, get your configuration file, put it into your application, add the Firebase SDK, and then you can use the same code that we generated to call the API because the API surface is literally the same. Plus, you don't need to put an API key in your application, and you can use AppCheck to protect your app. And this is how it looks like. So this is a function that is in the application, and this is the one that I use to summarize articles. It takes a string, which is the full text of the article, and is asynchronous because we will be using a remote system. Here is the call to vertex. So we get the vertex singleton, and then we just call generative model to instantiate the model, and then make the call to generate content. And that is the remote system call, and that is why we need to call it using await. And here is the response. And then we can take that response, return it, and do something with it. So let's do another quick demo. So let me find an article that I haven't yet summarized. I did summarize this one. Let's take a new one. So okay. Any suggestion? Antoine finally? Everybody good? Swiftly? Oh, Swift leads. No, Swiftly. Swiftly. Okay. So memory consumption. That sounds great. Okay. So I think there is. Yeah, let's try this. So adding, and then let's go back to the application. Hopefully that worked. There we are. Okay, here is the article, and I can now go in and have it summarize the article for me. This blog post discusses how to manage memory consumption when loading images from disk in a SwiftUI application, and so on and so forth. The article concludes by emphasizing the importance of efficient image handling and offers resources for further learning. I think that is a very good summary of this article, and it helps me to save a lot of time. So well done, Gemini. Yeah, you can clap. All right, so the conclusion, you can use AI Studio to prototype your prompts and then use the Google AI SDK to call LLMs from your client. But because that requires you to put an API key in there, you should be using the Vertex AI and Firebase SDK to perform calls if you want to go to production. Secure your application with AppCheck, please, so that nobody can hack your backend resources and cause you a huge bill that you don't want to pay. And now the question is, should you be calling that LLM straight from the client? What we did, right? So we made an LLM call from the client. And I think for this use case, it was a good thing to do because we already had the information on the client. We already had the full text of the article, so we didn't have to do another server round trip. But sometimes there are situations where you need to tap into more data, right? For example, you might have a huge catalog of products and you want to get product recommendations. Or you have a larger collection of articles than I did here on my phone. Let's imagine I've used this application for years and years and years to collect articles, and now I have thousands of articles in my knowledge base. And I certainly wouldn't want to pull all of these down to my client and then call the LLM from the client. So going one step further, let's implement something that requires me to tap into a larger database, and that is chatting with my second brain. And to understand what we need to do here, we need to talk about two concepts. The one is vector embeddings, and the other one is retrieval augmented generation. Who here has heard about vector embeddings before? All right, very few people. Who has heard about retrieval augmented generation? Okay, probably the same people. So what are vector embeddings? So let's imagine the task is to find all words that are food in the following sentence. So I gave this talk at iOS Dev UK for the first time, and that is why we have Aberystwyth in here. So I went down to Aberystwyth on foot to buy some Welsh cakes and a few berries. When I finished doing my groceries, I had a latte at coffee number 1, really exists, where I met a few other speakers. This actually happened. So for us, it's easy to know that Welsh cakes and berries are food items and latte. And we also know that the berry in Aberystwyth is not food, and groceries is the concept of going and buying the food items, and coffee number 1 is a shop and not food. But for a computer, it might be a lot harder, especially if you have just a dictionary with items that can be food, and then you try to find them in this sentence. So we need something else. And this something else are vector embeddings. So a vector embedding is a numerical representation of a word, a sentence, or any other unit of text, or even images. So what does it mean? Let's look at this thing here. And this is actually the first part of a vector embedding for food. And you will see that it is an array of floating point numbers. And those floating point numbers range from -1 to +1, and they represent this food item. So if we look at foot, which also appeared in the text, it is a different list of numbers. So it's a different vector. So that means that every single word, every single sentence, every single text can be represented using those vectors. For us, looking at those numbers, that is probably hurting our brains. But for a computer, that's a lot easier because we can use maths to deal with those numbers. To understand this, let's look at a vector that all of us know how to handle. So who here knows what this is? Yeah, please.
So longitude and latitude.
Longitude and latitude. And does anybody know where this is? Yeah. It's here. Yeah, exactly. Well done. So these are the coordinates for London. And these are the coordinates for Paris, London, New York, and Boston. So if we put that on a map, and if we look at all those pins that I placed there, it's easy to see which ones are closer to each other and which ones are more distant from each other. So for us, again, easy to see, but how does a computer do it? We can use what's called cosine vector similarity. So we will just use the cosine to compute the gradient of a vector, because any two-dimensional vector can be put on the coordinate system. So if you think back to maths, for me it's a pretty long time ago, you will remember coordinate systems, and then you can put your vector there, which goes from the 0 point to the two-dimensional coordinate, and then you can compute the angle, and then you can compare those angles using either sine or cosine, and then using the result of that, you can tell if they are further away or nearer to each other. So this is how we can compare vectors, and this is what we will use to compare those multidimensional vectors. So for us, two-dimensional vectors are easy to understand, multidimensional vectors are hard to understand, but still, like, the maths is the same, and for a computer, it's relatively easy to do. So how does it look like in code? This piece of code here is a cloud function. Who here has heard about cloud functions before? All right, nice. So cloud functions for Firestore is basically the serverless product offering from Firebase, and it allows you to write code in TypeScript or JavaScript and run it on the server without having to set up the server or worry about applying your security updates and all of that, because that's been done by a team at Google. And you also don't have to worry about how many people are going to call your cloud function, because we'll automatically scale it for you. And this particular function here, on document written, is a Firestore trigger. So it will be called whenever a document is written into Firestore, into our database. And I didn't mention it, but every single article that I save in my application, I write into Firestore. So it's a document which has the URL, for example. All right, so this function will be called. Then we will read the data from the document. So we will get information about the URL, for example, and the full text, because these were pieces of information that we stored into the document on the client. And then here, we make a call to the embed function, and that is a function that is part of Genkit, which is another framework that we'll talk about in a little bit more detail at a later point. And it will call an embedding model. So the embedding model will then take the text that I pass in and compute the embeddings for it, and I'll get this array of 768 floating point numbers that I can then store back into the document. So this function here is responsible for computing the vectors whenever I store a new document or update the document in my database. And this runs automatically. So whenever I save a document from the client, whenever I do it manually, this will always run. And this means for everything that we've got in the database, we've got embeddings. So this is only the first step. The second step is called retrieval augmented generation, and it consists of 4 other steps. So the first one is compute embeddings for the user's query. So when I go in and ask my application, hey, can you please tell me how I can use Swift to implement a hero animation, for example, we will first take that query string and compute the embeddings for it. So again, we've got this vector of numbers. Next step is find the nearest neighbors. We take this array of numbers and then we send it to our database and tell the database, can you please find me everything in the database that is close enough to this vector here. And it will use cosine similarity search to go through all of the documents, using an index, of course, and find the ones that are closest to the vector that I presented. And I can say, you know, I want to have 3 documents or I want to have 10 documents, so I can specify how many documents I want to get back. So let's say I've requested to get the 5 most similar documents back. I read those documents, I take the full text that is stored in those Firestore documents, and then I combine the text into a longer text, and then I inject it into a prompt. And that prompt I send to the LLM and tell the LLM, can you please answer the user's question using this text that I presented to you. So why is this important? LLMs are trained on publicly available data on the internet. So, and depending on how quickly the model gets updated, stuff that I publish on my blog, for example, will be in the training set of the model. But if the model has been updated last week, for example, and I've published in the meantime, that text will not be in the training set of the model. Or if I have data that is not public on the internet, it will never be in the model. So I want to provide this additional context for the model so it can act on this and generate an answer based on this additional grounding. All right, so let's take a look at how this looks like in code. This here is another Cloud function, and again, it's written in TypeScript, and it uses the Genkit AI integration framework. Hence, we can use this function called onFlow. Here we define the input schema, and that is what the client, when it calls this flow, will send. And you can see up here that I specify there will be a question that I send. This is the user's question, and because it's going to be a chat, I also want to send in the history. So the history will contain the entire conversation history between the model and the user. Then I use Genkit's retrieve functionality to go to the database, which is Firestore. You can see the Firestore retriever here. It will fetch the 3 nearest neighbors for this query. And it will automatically, so you will notice that I don't specify that I want to compute the embeddings for the query. That is what the retriever does for me automatically. So the retriever knows I first need to compute the embeddings for the query, then I need to go to Firestore and find the nearest neighbors and give back the result. All right, here I take my documents, the 3 nearest neighbors, I combine them and separate them with line breaks. Here I go through the history that the user has passed in and combine it as well. And this is the prompt. So this is moderately complex. It starts with telling the LLM who it is. I provided a little bit of detail about who made it because I thought it was fun that I can ask the model, hey, who made you? And then I specify the purpose, utilize my personal knowledge base to answer any questions I have. And here, at this point, I inject the user's question. So for example, tell me how to use macros in Swift. Then there is a list of instructions on how to behave. For example, in order to prevent the model from going out on the internet or using training data from the internet, I tell the model, hey, please prioritize the information that is from the personal knowledge base. If there is not sufficient information, clearly state that you don't know the answer, don't fabricate, don't hallucinate, and all of that. And then if I ask you about what you know, tell me that you only know what's in my knowledge base. And when I ask details about you as a person, just provide basic info and then try to get the conversation back on track to talk about knowledge in my knowledge base. More expectations? This is where we inject the context. And this is where we inject the history. Then finally, we go out to the model, tell it, hey, please take this prompt, generate an answer, take the answer and send it back to the client, which is our Swift application. So let's try this. All right, so let's start simple. Who are you? I am Sophia, a knowledge assistant created by Peter Friese, a developer advocate on the Firebase team. All right. Who made you? I was created by Peter. All right, so let's ask something about Swift. How can I call Firebase Friesebase? Well, funny enough, I play bass. Firebase from Swift. So let's see if there is enough data in the knowledge base. All right, so here we go. Add the Firebase SDK to your project, initialize Firebase, use the Firebase API, authentication. This looks good. All right. Okay, now let's see if it understands history. I want to use async await instead of closures. Oh. Okay, let's see. You're asking about how to use async await instead of closures. While Firebase APIs often utilize closures for handling asynchronous operations, async await is a more modern and often preferred approach. That's absolutely true. Unfortunately, I need more context to give you specific advice. Could you tell me which Firebase service? Okay, Firebase auth. Let's just say auth. Okay, you're interested in using async await with Firebase authentication in Swift. Here's how to do that. So let's see, where is the call? Yeah, there we go. So it uses async await to talk to Firestore and also gets the user credential. Yeah, so pretty good. Well done. All right, but let's see if this also works. Siri app intents. All right. Search my second brain in Sophia.
Sure. What would you like to know?
How can I become an indie developer?
Here is your answer.
Okay, so it was still able to. Come on, no Siri, don't do that. Okay. Let's try a different question. Speak to my second brain in Sophia.
Sophia hasn't added support.
Yeah, see, that's the problem. You need to know exactly how to talk to it. Search my second brain in Sophia.
Sure. What would you like to know?
How can I call Firebase from Swift?
Here is your answer.
All right. Yeah. Okay, so sorry about that. So it depends on how much information I have in my knowledge base, obviously, and sometimes it works well, sometimes it doesn't. Personally, I feel Siri is still a gimmick. Let's be honest. So the chat, that was a lot more useful, and also, once I fixed those UI issues that you saw, you could imagine that you could copy and paste text from that, and that is so much more useful than have Siri even display a dialogue. But for the sake of the argument, let's look at the code. So to hook into Siri, what you do, you define an app intent, and then you define the parameter to pass in the user's question here. And then there is a perform function, and that is the method that really goes out and talks to your backend. And as you will see, it's pretty straightforward. So we call this service, which I implemented myself, which just talks to this flow that I showed you, the TypeScript implementation, sends my question, waits for the answer, and then returns this dialogue. And the reason why it was able to show nicely formatted text was that I'm using this Markdown implementation by Gonzalez Real. It's fantastic. If you need to do Markdown in SwiftUI, look no further. It's perfect. Well, close to perfect. But yeah, it's amazing. And this is how I built a second brain using Firebase, Gemini, Genkit, and Siri. Yeah, so we've got time for 2 questions, and after that, there'll be a break with food. So I think we've got microphones to go around. We've got 2 microphones back there. We can have microphone runners. Back there.
Hello, nice demo, thank you very much. How much did that cost?
The application?
No, to run what you just run, all the AI.
Oh, how much did it cost? All right, so thanks for asking. Let's go and take a look at that. So I can go into the Firebase console. And then, so here's my project. Oh, okay. All right, so I don't see it here, or do I? All right. Use a different account. Go here. All right, so we have a new feature called AI monitoring, which you can use to see all the calls. And you can see that I've been playing around with it quite a bit. So if I show you, last 14 days, you will see that I sent in 1.6 million tokens and got 48K tokens back. You can also see, the curve. You can see stability metrics in terms of total requests, error rate, mostly programming errors for, not providing variables and stuff like that. And then this semantic QA flow, that is the thing that we call all of the time. And to see it, we can go into Cloud Trace. So first of all, you will see all the calls that we did here, and I can go in and see what happened. So you can see that the flow consisted of several parts, so I fetched the data and so on and so forth. But you asked about the price. So let's go to billing, go to my linked billing account. And there is a bunch of projects on there, so don't worry. we will filter this down. So I'll go into the report. And now I'm going to select just my project. So Sophia development, there we go. The blue stuff, that is our vulnerability scanner. And let's filter just August's. August 23, that's quite a lot. Let's go to August 24. And then all services, all SKUs. Let's take just one day. It should show me project. So let's filter it down to vertex. Okay. So for the past couple of days, it was just 8 cents. So it's not a lot. So I was trying to show you the view where you can see our vulnerability scanner kicking in. So that kicks in for every deployment. So whenever I deploy a new function, a new version of the code to Cloud Run, it will basically run and see if there is any malware in my code. And that costs 26 cents per run. So that is what's most important, most expensive about that. But calling the LLM actually is quite cheap, I would say. Yeah, you're welcome. One more question? There's a question at the front here.
Yes, actually.
Let's use a microphone so everybody can hear you.
Sorry, I was just interested in how you built your first app, because that's really that's why I came. I read a lot. And
How I built my very first app.
How did you curate? Yeah.
Okay.
So I knew this stuff.
All right. So I will. I was born when the Rubik's Cube was invented. And my first, the first program I wrote was a basic, GW basic program for encoding texts using Caesar cipher. Back then I thought, oh, what a smart idea to just like advance, an A becomes a B. It's super hard to read. Little did I know. And then the first real application that I did was a vocabulary trainer. And I used that to learn my English, my French, my Latin. It was so good that when I made a typo, I learned the typo as well. And that was written in Quick Basic. So back then, everything was DOS, text interfaces. So a long, long time ago.
Sorry, I meant the first app that you curated.
Sorry.
But this was interesting too.
So you mean the first article I curated? I don't know. So you'll have to go to my newsletter and browse to the very first episode to find out. All right. I'm happy to take more questions outside, but let's go for break. There'll be food, more drinks, and after the break, we'll have 2 more speakers.